All right, welcome everyone. Today we have CITP's very own Dominik Stammbach. He's a postdoc here and he works with Peter Henderson. A lot of his work looks at natural language processing and it's used to make for legal professionals to make it more accessible for justice. He's also done some work on using NLP to detect misinformation, particularly in the climate change area. Dominik got his PhD at ETH Zurich and his master's in language science and technology from Saarland University. Dominik's here, he's doing a lot of work on the use of NLP, particularly in the public sector, but particularly for legal professionals, is that right? Yeah. So for legal professionals, Dominik's slowly also becoming an expert in doing interview studies, as of last week, I think, right?
Fake it till you make it.
Yeah, so, and we were hoping today we would have some McDonald's because Dominik's also interested in American fast food, but that didn't happen. But we're excited about Dominik's talk on legal NLP for public agencies.
And thanks a lot for the introduction. And before I start, I love this to be interactive. So I love to take questions throughout if I talk about something which is unclear or you don't understand. And it's always sort of tricky to me to talk to an audience which is not experts of computers, like computer scientists, people or natural language processing people. So if I go too fast or something is unclear, just interrupt me at any time. I want to structure that talk in sort of three sections. First, I give a bit of a background of the motivation, that is the access to justice crisis in the US, and we sort of hope that AI or natural language processing can be an equalizer here and increase access to justice overall, and how that looks like. And then I want to talk about two ongoing projects which are very much work in progress, and I'd love to hear feedback on that or things we might have missed. And then I'll give a brief outlook on what we're planning to do next. This sort of is an overview of the problem. In the US, you, I think, have a right to legal representation in criminal cases. This is stated in the Sixth Amendment. And so what that means is, if you're charged with criminal cases, but you don't have enough money to hire an attorney, you would get assigned a public defender. And then that person would take care of your legal representation. So everybody's like, say, equal in front of the law, but in practice, this unfortunately looks slightly different because public defenders seem to be notoriously overworked and underfunded, and it didn't take me more than 30 seconds to come up with a few examples of newspaper articles sort of mentioning that phenomenon. We sort of hope that NLP and AI can help, and they can help public agencies or public defenders, and by empowering them, by assisting them, taking care of repetitive and time-consuming tasks, that those people have more time to actually take care of the legal representations of their clients. And we hope that this can motivate legal NLP research, and we sort of push for more grounded legal NLP work, and we hope this sort of is a strong motivation and can inspire research questions for applied NLP work there. We have written that paper in late 2023, where we do a literature review of legal NLP work, and what we find is that most of the NLP work there is mostly computer scientists talking to other computer scientists, and all of the authors of such papers are computer scientists. We just find a small fraction of interdisciplinary work, and we just find one paper where, you know, lawyers are trying to talk to computer scientists and be a bit like, hey, perhaps this is what you should be doing. And also, most of the legal NLP tasks we find are about legal judgment prediction. So you sort of have the facts of a case, and then you try to predict the outcome in court. And given these findings, we make the following argument. So we sort of write about the access to justice crisis in more detail, and we hope, and then we sort of say that we wish for more research which is related to increasing access to justice and work on like useful applied tasks. And then we also urge for more interdisciplinary work, because legal NLP in a weird way is a kind of tricky thing, because it has a very high entry barrier. If you don't have legal training, it's hard to make sense of legal data sets. Also, there aren't too many legal NLP data sets for real world tasks. My personal view is that most people work on legal judgment prediction because it's sort of intuitive what is going on. And there are just existing data sets out there which you can then take and train machine learning algorithms and so on. But like, it's not necessarily connected to access to justice or something different. And if you want to go the more complicated route, you'd work with legal collaborators, try to understand more deeply what is going on, what is needed. But then like that work sort of becomes more complicated and less straightforward. Having said that, we try to develop legal tech for public agencies, which is developed in an interdisciplinary way and directly aimed at increasing access to justice. And here I want to talk about two projects. And the first one is a collaboration with a public defender's office on the East Coast. And we're talking to them since last summer. And they tell us that they have like a large centralized brief bank of around 3,000 briefs. And in practice, that sort of means that if you're a public defender there and you get assigned a new case, you would, like they have that word of mouth thing, you would ask the people in your office, hey, have you worked on a similar case in the past? Can you point me to a related brief? And then that could inspire like legal arguments, or they could find relevant precedent cited in that case. And so they tell us that this is happening anyways. And then we were thinking we can't just build a search engine over those internal briefs, because that might be more efficient than just those people asking others until they find something. And eventually, if we have that, we also want to do a retrieval augmented generation legal writing assistant, but we haven't started that yet. Now, legal search is sort of difficult because it's like if you have search in natural language processing, it's often like I'm just finding passages with the same words is what gets you very far, but this doesn't seem to be the case in legal search. So if you have questions like can officers, like your queries and your passages are just sort of semantically connected, but they don't always have the same words in there. And then the other thing is there, as far as we know, there do not exist real-world legal retrieval data sets. So most of the things we can do is just zero-shot. And here are a few legal retrieval data sets, but they're all not very applicable to what we're trying to do here.
What do you mean by a real-world data retrieval data set in other areas, for example?
So as far as I understand, the most famous retrieval data set is MS Marco. And MS Marco is Bing queries, is like 100,000 Bing queries and search results, which people actually clicked on. So if so, and then this sort of is real world because you have users querying Bing and then getting search results. But legal retrieval data sets, like I have written this for a paper here, and what we do there is we go through all case law in the US, and then we identify the most cited passages. And then we take the preceding context, where a opinion cites a passage, and then we say, hey, given this preceding context, you have to retrieve this cited passage. But like this is not like how public defenders would query a search engine.
I see. So you don't have like user trace data from
Exactly,
people
yes,
using
yes,
these data
yes,
sets, right?
Yeah, and I'll show in a bit how this makes things more complicated.
And you mean this publicly, right? I mean, there's Lexis and Westlaw.
Yes. Now, there's a bit. Yeah. Yes. So there is that other catch that Lexis and Westlaw offer two types of search. One is Boolean search, and lawyers actually get training, or like during law school, I think everybody goes through training how to use Lexis or Westlaw. The other is they have those AI chatbots, and yeah, nobody knows how lawyers actually use them or what queries they ask because this is not publicly available. But yeah, those companies must have something. So what we built is a search engine. We signed a MOU with the Public Defender's Office, so we cannot display search like results over their internal data. So I just indexed all of the New Jersey case law since 1990 and used that as a demo, and I hope that works. And this is what our search engine looks like. Like here you can enter a query such as, can officers order passengers out of a car? And then you can search, and this takes around 5 or 10 seconds. And live demos are tricky, but they work. And then sort of the first retrieved result is this date v. Matthews, and here it says, like this passage here, that in the New Jersey Constitution, passengers have greater rights than the driver. Manuel, you look skeptical.
No, but I'm just asking, like the passenger has greater, so you can order the driver out of the car, but not the passenger.
Yes.
Okay, that's what I didn't want. Just
Oh.
Yeah.
No, I was thinking, I was thinking what it meant. Sorry.
Yeah. And then we implemented that. We also implemented like an up and down vote button so that public defenders can up or down vote search results, which we can use to build a data set. And then they can also submit additional feedback for what they expected or how they interpret the results, or also for briefs. Like we asked public defenders to also search for briefs they know are in the data set. And if they were not retrieved, they could just list that there. And if anybody has a question about New Jersey case law, happy to run it.
Have they given a lot of feedback back to you on how to improve your search engine?
Say that again.
Have they given a lot of feedback for how to improve?
So we've been evaluating that for perhaps 10 days by now, and we have feedback for around 100 queries, and I'll go into that in more detail in a bit.
Okay.
So one sort of thing that the Westlaw Lexis gives you, right, or those equivalents is also the precedential value. So has the decision been overturned, or what's the subsequent history on those decisions? Is there a way to build that in?
We hope so, but we don't really know how to do that yet. And the way I understand it is that they sort of have that data, which is manually curated. So whether a decision has been overturned at some point, and then they can add that to their search results. But we don't have that data, and we are not sure whether there are ways to get at that automatically. But yeah, this is like one of the challenges. But yeah, we want to look into that at some point. And then I try to go back to my slides. I also added a screenshot of that demo in case the demo would have failed, which happened to me 2 weeks ago. And I was presenting that, but then I didn't have a screenshot, and then I had to say, please trust me that we have a search engine. So, and this is sort of what we did in more detail. We used large language model chunking. So we took a open source language model, a llama model, and we said, hey, here's a brief, chunk that into thematically related chunks. And then we have freed out 2,900 briefs, which yields around 120,000 chunks. We index all of those with a model called NV embed v2, which is built on a large Mistral model. And back in September, this was like the best open source embedding model on various retrieval benchmarks. So we just figured, let's take that and build our index with that. And then we can run the retrieval. We also have sort of extractive question answering. So we give this query and the passage to a BERT model, which tries to predict the most relevant span in the text. And then we bold that in the hope that this makes things a bit more accessible. And then we, like in the search engine we've built for the Public Defender's Office, we also give them the retrieved documents, which they can then download, and we automatically highlight the returned passages. And then we have some preliminary feedback from public defenders. They are testing that search engine right now. We have results for around 90 queries. And by and large, we see that around 60% of the paragraphs returned are being uploaded, which we think is very impressive, because that's like not a legal retrieval system, it's just a generic sort of existing embedding model. But we also find that 40% of the returned passages are not good. And we also see that the calibration of the model is working quite well. If the model predicts a very small distance between a query and a passage, our public defenders think that the passage is more often relevant, which we take as a good sign. And if it's a larger distance, then more of the passages are annotated as being bad. We also have free-form text feedback, and I just tried to summarize that into a few categories. And the most frequent category we got is that all the retrieved results are bad, which was sort of challenging to learn. But also we can improve on that, so I take that as a positive. We often got sort of a mixed result feedback, so the public defenders would say the first 2 results are good, but the last 3 results are bad. Then they also complained that there are passages from the same brief. And sometimes they gave us compliments, they said all the results are great. That was really nice. And then they also said things like recent briefs would be better, or what Mihir said, like, I think one of them said, I think this, like the brief here was overturned recently, so this search result is useless, and we're thinking about how to improve it. We then looked into the queries the public defenders have entered into our search engine in more detail. And I like to think that we sort of have a consistent theme here. And that is, we have 2 different kinds of queries. We have more generic queries, such as, can officers order passengers out of the car? And these work rather well. But then we also have domain specific queries. And I've rewritten those for confidentiality reasons, but they look like that. And this is where our retrieval model fails. But then I don't think this is surprising, because this very much seems out of the distribution of what our retrieval model has been trained on.
But it's not out of the distribution of what people use it for.
Of what legal people use it for, yes, exactly. And then sort of the challenge is, how can you bridge that, right?
Can you have the model rewrite the query? Could you have a scenario like I see this a lot for image generation tools
Yes.
where kind of like people are actually not good at prompting the image generation tools. So in some cases you write like cute cat or something, and then like there's actually an engine behind that says a cute cat is looking by the window with like a little plushie. So it has some sort of automate. I mean, it's a different case, right? Because there's adding detail and complexity. But could you try to have a system that like hijacks the query, says, okay, this is actually something that is likely more phrased as an LLM question.
Yeah, like this is a fantastic suggestion, and I also gave a version of that talk last week, and that was also suggested. And the short answer is, we hope that this will work, and we plan to implement it, but we haven't yet, and we also don't know. And there are a few perhaps practical limitations here, and that is that we want these things to run fast. So like if a public defender enters a query, we sort of discussed with those people that a search result should be returned within 10 seconds. And if we start rewriting things or doing some agentic things in the background, things would usually take way longer. So we're not quite sure how to make that fast, but it's something we want to look into. Yeah. What we did next is we took those annotated queries and we just further fine-tuned our model, but then we learned that our experimental setup in a way is difficult because we have a model and then like all our annotations are sort of in the top distribution of that model. So all like the recall of the uploaded queries for that base model is 100%, obviously, because that model has returned those results. But also the recall for downloaded queries is 100% because that model has returned those results as well. So if we fine tune, or like if we want to improve a model, what we sort of want is that recall for uploaded queries stays high, but the recall for downloaded queries gets very low, and those don't get returned anymore. And then what we see is sort of if we just fine-tune on uploaded results, we try to make distance between a uploaded paragraph and the query small, and then we lose some of the return queries. So we just have 70% recall. And our interpretation here is that like if a query just has 2 uploaded results, we retrieve one of them, we don't retrieve the other one, but like whatever we retrieve otherwise would have been better than the other uploaded result anyways. We just have 50% recall, but it's sort of difficult to measure. Yes.
So your upvoted, downvoted have quite a few reasons why they may be upvoted or downvoted.
Yes.
And so if you're fine tuning on that, you may not calibrate to the reasons why it's being upvoted or downvoted.
Yeah, that's also true. Yeah. Like we lose that signal. Yeah.
Yeah, and so, if it's being upvoted or downvoted because it's not, like you're putting a lot of strength into that one signal that's actually some disaggregated thing.
Yeah. Yeah. Also, we were thinking perhaps our this up and down vote might be sort of noisy because we have different people interacting with the system, and some people might be more strict in upvoting, whereas others are more lenient. So we are putting a bit too much trust into that signal. But then we think there are still some options here. So like if we also include downvoted results as sort of hard negatives, so we tell our model to make the distance between a downloaded result and a query as large as possible, then the recall on downloaded queries goes down a lot. So we think there seems to be some consistency and something we can improve. But still, those are preliminary results. We hope to get more annotated data soon, and then we'll see where to go next. Like to add a bit to that story of what do we retrieve instead? Like so sort of here in the second row, we have 70% recall. So we retrieve lots of queries which were neither up or downvoted, and we retrieved lots of paragraphs which were not upvoted or downvoted. So we want to use a large language model to make an educated guess whether this would have been a upvoted result. And we do that by simply training a llama 8B model on distinguishing whether a query paragraph pair would have been upvoted or would have been downvoted. And this model gets sort of around 80% precision and almost perfect recall on a held out data set. So we hope that this is quite a good proxy. And then we just predict whether the returned results from our fine-tuned models would have been better or not than what we had in the zero-shot setting. And I kind of like this because I think it tells a bit of a more nuanced story that for generic queries, our base model gets around 67% good results, which I think we also sort of see here in that left plot. But then for domain-specific queries, it gets like 50% good results. And then if we fine-tune on those up and down-voted queries, we get better at the generic queries, but we're not really making progress on the domain-specific queries. And then we thought, okay, is there an easy way to fix that? And then we generate lots of synthetic data. So we do a few-shot prompt, and we generate 2 queries for each paragraph in our data set. One is a more generic query, and one is a domain-specific query. This gives us a data set of 100,000 synthetic query paragraph pairs. We take those and we further fine-tune our embed V2 model on that. And what we sort of expected to see is that the predicted results would go up for both. But what we sort of see in practice is that our model just has 30% recall on uploaded queries, and also our model, which tells us whether the retrieved results are good or not, is saying that the retrieved results are not that good.
Can you explain recall just briefly?
Yeah, sure. So like if you have a query and you have 2 upvoted search results. Yeah. And then you sort of modify your model, and then this model retrieves both of those upvoted search results. You have 100% recall.
Right.
If your model just predicts one of those search results, you have 50% recall. And if it doesn't retrieve any of them, you have 0. So yeah, sort of how many of the upvoted results.
The model returns what was already upvoted.
Yes, yeah. And sort of here we see that that piece.
So if you have like a model that's upvoted and like later on it's downvoted by somebody else, like how would you calibrate that?
We don't have that yet, because we have sort of 100 queries, and they're all unique. So for each query paragraph pair, we just have one signal. But yeah, like if we would be running that for a while, there's a chance that this eventually might happen. And we haven't thought about that. But I think the most straightforward way would be to just discard all of those.
It's worth noting that a lot of the things you're doing, like you're kind of like reinventing recommend like search, right? Because like no one has worked on search since it's been a commercially established problem. But a lot of these problems are exactly the same problems. If you get like the typical 2000s book, which is the Baetza Yates book, Modern Information Retrieval, I slacked you. Like it's all about this, right? It's like all about like how do you get signal if you don't have any signal? How do you do this? So it's like these problems that like were mainstream at some point in computer science, but like because like search stopped being a kind of like a research topic and became a commercial product, like they left. But yeah, like one thing that is like worth noting there is that like ultimately you should think about like other indirect ways of getting user feedback, right? which is what Google does. You know, like they have very sophisticated ways of trying to tease out this feedback from you. For example, did you make other queries? Was this your final query? Or like, in your case, I think that the most valuable thing perhaps would be, do you have access to the final report that like that the lawyers have created, the public defendants have created, right? And can you basically trace the queries? Like, because you could just make this very simple link, like these were this person's queries. This is actually what was cited on the final report. And you could just use this, like, if you have this through time, this is perhaps the best setup, something that Google would never have, right? Because they never fully have your entire trajectory of what you did, right? And in this case, there's a concrete output that you can look for.
This is absolutely fantastic. We were sort of thinking about using that in a different way, and that is to measure like uptake of our search. So our hope was that like if people use our search tool and then they sort of copy paste the returned results, then we could show that our tool is useful because people use the results. But taking that as a further training signal makes tons of sense.
And you could imagine doing synthetic training data from this by basically getting reports that already exist. Like just an idea, right? Like you get reports that already are out there, right? And these are public documents, as I understand. Like you can have access to them, and you just say, like, you just have a systematic way, which would be an LLM generated way, to say, hey, if I were to write this document, what sort of questions would I have to ask? So you can imagine coming from this place of like, hey, I have the full document. I write the questions that like I would need to answer, like the legal questions that are relevant for these documents. And then you would place as upvotes those documents, the whatever was cited in that original document, right? So that is something like that you could do, right? Like you could, because I guess that the big problem of here is that you have this chicken and egg problem you don't have the like specific thing because you don't have that. So why can't you just use the fact that there are, like, I don't even know how many, but like probably thousands of these documents publicly available to create the synthetic data, right?
Okay, this is fantastic. We haven't thought in that direction yet, but we absolutely should explore that.
Yeah, this is the kind of thing that people did. Like, if you look at this like super early recommender system things, like they had this, like, can we get indirect user trace data from whatever, like for music or whatever, right?
Okay, I should also look into that earlier literature as well.
Yeah. And it's a little bit challenging in this domain, right? Because the things you're looking for are cases, and then you may reuse it or update it, and so it'll be hard to see the signal from the search into an actual end result, because they might just be looking for some citations that have used it, and then those citations will repeat. But you may not be able to trace it back to the fact that you retrieved that for them. Like the signal between
that's fair.
So that, but it's a totally.
Like I also think if this works in some cases, this would be a signal. All right, it doesn't have to work always.
Right. I mean, maybe if you see that certain paragraphs repeat or something.
Yeah, exactly.
If you had some interface where there's a, you know, like if you had some interface where they could split this by, this is, you know, like you could imagine like the productization of version of this would be like, hey, you have this like project within your like API, and there you can aggregate the queries, you can retrieve whatever you searched for, you can find that. Then like if you have some incentive for them to say case blah 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 and link this, you could avoid. But I don't know if this is legal or like I don't know if this would be like something that like would present practical issues to you.
But this is fantastic input and something we should look into. This is like my last slide on that project. We also sort of learned like, and these are helpful features we're thinking about implementing, but we haven't fully yet. So I was thinking perhaps you can just add like a green or a yellow circle to a search result. A green circle being our model is confident that this is good. A yellow circle meaning that we're not quite sure. with the hope to sort of get at that thing that we do know that not all of our search results are good. And the other thing, but yeah, we have to discuss that with our partners. Mihir is shaking his head.
It's fine. It's just like, it's a very, but green and yellow is usually a signal of whether it's good law or bad law in Lexis or Westlaw. And so
Ooh,
you're,
okay, I
you're,
did
you're
not know
messing
that.
with somebody's
Okay, yes.
priors on that, yeah.
The other feedback we got is like sometimes our return paragraphs are not detailed enough. So we thought about like having a read more button, and if you expand that, it would show you a summary of the brief or the case. But then this summary is AI generated, so it might contain hallucinations or errors, so we're not quite sure about the trade-offs of adding that. But it's something we have implemented, and we want to discuss whether this would be helpful to implement, to roll out or not. And now I want to slightly switch gears. This was our first project about legal search. In our second project, we are doing an interview study with public defenders, and by and large, we just want to understand in more detail how they work and what they need, because we also realized that while implementing the search, we didn't necessarily know what a public defender might be looking for, and we might build a better product if we just understand better what they need and want. We sort of want to answer 3 research questions here. The first one is, how do they work? What tasks could be assisted by natural language processing or AI? And then lastly, are there unique constraints like confidentiality or time or money? And we just started setting up those interviews, and we interviewed 2 participants last week. We're going to interview a few more this week, and we're also trying to recruit more. So if you happen to know public defenders and you could put us in touch with them, this would be amazing. And here I want to take like 5 minutes to sort of talk about the early insights from our last week interview. And the first one is whether public defenders are enthusiastic about AI. And I'll just continue. And we find mixed results. So we had one participant who was super enthusiastic about AI and knew a lot about AI, and the other participant not so much. And we're curious to see how this, what this will look like after we conducted all of our interviews. We also asked how they use or do not use existing AI. And then it was sort of interesting because the one participant who was enthusiastic about it walked us through how that person would use AI. And he said that he mostly used it to sort of like get an understanding of the concepts or the keywords he has to look for to understand more about the case. And then what he started with is he just copy-pasted a fact pattern into ChatGPT and said, give me a broad overview, and then he would look through those results and think, yeah, this is a good concept I didn't know about, and then he would Google that or go to Wikipedia and read more about it. And we were sort of surprised because we thought what a public defender does is go to Westlaw and start like searching for some keywords, I guess, but then this is absolutely not how they approach things. Also, we learned that a Westlaw subscription might be prohibitively expensive for public defenders, given that they don't use it that often anyways.
How much does it cost?
I think it's around $250 a month, but don't quote me on that. Yes.
Have you looked into whether the ABA gives lawyers any guidance about whether they should do that thing? Because they might be revealing to you that they're violating legal ethics.
Yes, so we briefly talked about that. And he said that like he wouldn't copy paste confidential details into ChatGPT, but like sort of try to remove those. But then we also heard that that participant said that he thinks using ChatGPT is completely fine because OpenAI guarantees you some sort like confidentiality on your
On what? Go ahead.
like on your user queries, or they wouldn't train on it. And then he said that this to him is similar as using Google search or Microsoft Word. Uh-oh.
Maybe we
It's
need
his
more
decision,
trainings,
yeah.
It
yeah.
depends on which contract you have with OpenAI and what they guarantee you that they won't.
I guess this opens a window for more training to, you know, a lot of people really don't fully understand.
One like question, like, because I mean, I guess that there's these like commercial competitors that like offer basic functionality. Have you thought about implementing in general this as baselines for whatever you're proposing, right? Because like the one challenge that you have, you don't have any baseline, right?
Yeah.
And like you can, I mean, not implementing the whole thing, right? But like you won't be able to have the annotated data, but you could have like Boolean search if that's like the state of the art. Because like Boolean search kind of sucks as well, right? And like people are used to it, but it's also like most searches end in, like there's a reason why Google is not Boolean search. Let's say, let's put it this way, right? And like so it may be worth to implement it not like only to kind of have a control group for experiments and stuff like this. I don't know.
And like this is a good point, yeah. We hear.
No, I was gonna get back to you. I'll talk to you later about Boolean. Yeah, go ahead. Yeah,
You hate Boolean search?
it's excellent.
It's excellent.
I'll tell you why.
Yeah, we didn't have, we have briefly thought about a baseline here. Sort of the reason we haven't implemented it is because we want to be mindful of the time of the people who are interacting with our system. And we just think that non-Boolean search would give them more relevant results, and then they would be more enthusiastic about using that tool in the future again. Whereas if we implement Boolean search and we're a bit like, hey, like here's Boolean search over this and that collection, and then they use it 5 times and they think whatever they receive is not great. If we have like a improved version of that later on, they might just not read the email because they remember their bad experience with the Boolean search in the first place, and we did not want to risk that, but perhaps we should have. Yes.
Sam is-
Oh,
Yeah.
sorry, Sam.
I've seen some, well, 404 Media has reported multiple instances in which lawyers have been caught by judges for making use of LLMs like ChatGPT because they have referenced hallucinated cases. I'm wondering if in your system here, hallucination is of concern and how you are addressing that, I guess, by design.
Yes, so let me perhaps go back a few slides. So perhaps here, we sort of right now have a search system over briefs public defenders have written. And by construction, it cannot really hallucinate because it would just return things which they have written anyways. It might return something which have been overruled. And this is, I think, like the 2 major risks are first returning something which has been overruled, or not returning something even though it was in the database. So we think these are manageable, or like, you know, with sufficient training, with a bit like, hey, make sure that this has not been overruled, or if you don't find something, like there might still be something. And then we've also been thinking about generation, so this is sort of our RAG-based legal writing assistant. which we have not started implementing yet because we kind of know that hallucination is a major problem which we cannot make go away. Because implementing a like chatbot, which does something, is kind of easy, but like you just cannot make any guarantees about hallucination, so we haven't even started. We haven't started. Where are we? Yeah, and then we also talked about what they think would be useful AI tools going forward. And both participants so far said that by and large, they want something which finds the needle in a haystack. So if you do a Boolean search over Westlaw and it returns 100 cases and 2 of those cases are relevant, they would love AI to return those 2 cases, but not like the other 98. And also one of them told us that yeah, he once had to watch through hours of videos, or like it was one of those cameras which was aiming at a door, and then for hours nothing happened, but then at some point the door opened, and this sort of was the critical moment, and he kind of said that it was unnecessary to watch the whole video because in 99% really nothing happened, and if AI could tell him what parts of the videos he has to watch, this would be super fantastic. And also he said that he has to listen to hours of phone calls where most of the stuff is not relevant or interesting to whatever he has to do, but then every now and then you have like this 30 seconds or 1 minute where something critical is being said. And if AI could detect that, then he doesn't have to listen to all the rest. And we also talked to, we invited the public, the leader of a public defender, or the former director of a public defender's office to Princeton, and he said that something which would be super interesting is if we have AI which can go through all court records and automatically find reasons to appeal. And we thought this sounds ambitious, but very interesting. And I think this is sort of similar to having AI which can parse videos or phone calls or images. And perhaps this goes back to Sam's point, and this really puzzled me as a NLP person. Like they didn't say, hey, we want AI which, you know, does legal writing assistance, which, yeah, I was very surprised by. Yes.
Do you think there's a chance that, like, that's already being used, so they don't need it?
That might be true, yeah. But I think it's more generally that my take was that public defenders would spend a lot of their time writing, but apparently they're not. Like they're spending a lot of time looking through videos, phone calls, talking to clients, talking to people, representing them, and then only like a minor part is actual writing. And yeah, like my expectation was very different. And yeah, this is sort of everything I wanted to talk about. And we have collaborations with 2 public defender offices. In one project, we are interviewing people and ask what they do, what they would need, and what they are excited about. In the other project, we are building a search engine over internal briefs, and then perhaps we might or we might not implement a legal writing assistant at some point in the future. And in our paper in 2023, we made the argument that there should be more research on tasks which are directly related to access to justice, and there should be more interdisciplinary work. I sort of hope that in the 2 projects I just presented, we did justice to those recommendations we made back then. I gave a overview of work in progress, and then there's a bit of an outlook, but I might, how are we doing on time? How long am I
We have
supposed to?
8 minutes, depends on, like, people are, you're taking questions in the middle, so I guess it's fine. We have like 3-4 slides, right?
2 more slides, yeah. And like there is sort of, I kind of hoped I could just give them because I did them in like 2 minutes. So yeah, we want to implement some requested features, like perhaps also what Meteor said with overturned things. We also want to iterate on our current version, which we discussed with our partners at the Public Defender's Office, that we would like iterate on our prototype and gradually make it better. We want to understand in more detail what domain-specific queries look like and how we can make retrieval results better there. And then eventually we also want to do something metadata-based. So like if you have 2 returned results, one being from a brief in 1985, the other one being from a brief in 2024, you would always want to prioritize the one from the more recent brief, because chances are that this is more relevant, everything else being equal. And this is a sort of challenging NLP problem.
Don't you have the date of the briefs?
And we have that, but like sort of like what like it becomes a bit challenging in terms of if you have 2 retrieval results, and your model says for like how do I put that? If you have 2 retrieval results and one is from very recent and the other one is from way back, if you just heuristically say always return the recent result, you might make mistakes in cases where the recent result is not entirely accurate, but the one from 30 years ago was the actual spot-on result. So we think you shouldn't decide that heuristically, but you should include like metadata such as the year in your search, and then let a model decide.
Yeah.
Yeah. We hope it'll work, but we haven't tried it yet. And yeah, then we also hope that like we can learn some lessons in that project for partnership projects between academic institutions and public agencies by and large, what works, what doesn't work, what are some challenges. And we hope that some of the lessons learned here might go back to inform the legal NLP community about like real world retrieval or research tasks. For the qualitative interviews, we have a few more interviews scheduled in March and April. We are trying to recruit more participants. So again, if you know public defenders who would be enthusiastic about that, please reach out to us. And then we want to write that up eventually and sort of come up with recommendations for AI tasks, which would be relevant for public agencies or public defenders, such as processing videos, processing phone calls, or processing everything in court records. This is all joint work with a few people, with Peter, who couldn't make it today, with Inyoung, Paddy, Nimra, and Kylie, who helped in the, yeah, like in both projects. This is, I think, all I have. Thanks a lot, and happy